Okay, so I want to play with oxidizing stuff. What we have on the right is a 0.1 mole solution of potassium permanganate. It's 3.16 grams of potassium permanganate in 200 mils of water. On the left, we have a 2 mole solution of sulfuric acid. Permanganate is a much stronger oxidizer in the presence of an acid, and we're using sulfuric rather than hydrochloric because mixing hydrochloric acid with permanganate releases chlorine gas, which some claim is unhealthy. It's very unhealthy. So we're gonna see how this goes. But I don't really know what to expect of this. So that's why I am filming it. So let's swap the positions of these two and see what we get. So this is 0.1 mole, again, 0.1 mole KMnO4, and we're putting in 200 mils of H2SO4. Perfect, nothing. I actually don't mind that a bit. So it's not hot, but what I want to do is put some aluminum foil in it. If I ever actually wanted to do something seriously with a YouTube channel, I swear it should just be called like The One-Handed Chemist, because I'm recording everything with my left hand. So this is some aluminum foil that I oxidized or whatever yesterday. You can see this bottom part, crunchy though it is, and scrumped up, is just regular aluminum foil color. And this part has kind of a bronzy, aged C3PO kind of color to it. This apparently, I guess, will produce some hydrogen gas, although the sulfuric acid is not all that strong at this point. So what let's do, if we can scrunch it down this way, and then what we have is that the top of this little baton is just plain old permanganate. And the bottom, which we'll stick in there, is the permanganate that's supposed to be really highly, much more oxidizable. Anything? The oxidation potential of this permanganate with the sulfuric acid in it is supposed to be much, much, much greater. So give that a swirl. Okay, so we're back after, it's actually about 3 hours. That's kind of the gold, bronzy looking color from previously. We all know what aluminum foil normally looks like that. And then that right there is the oxidized part, and it looks a lot like it's just coated in, this like black ink looking stuff, but I'm pretty sure once we rinse that off that's going to be just like that. I'm pretty sure we've oxidized it that much, but it's not, it didn't bubble or do anything ridiculous. What's interesting is in the rest of the, this is the potassium permanganate sulfuric acid solution that I made and just left. There is a slick here, and I don't know what that slick is. Yeah, so I don't know. But anyway, we've got almost 300 mils of this stuff left. So I bought a while ago, 10 years ago something, a whole one of these sets of different kinds of screws and household bits, and I just haven't used the rest of them. So 1, 2, 3, 4, 5, there's 6 some kind of wood screw or whatever. I assume they're made of some kind of galvanized, whatever, something stainless steel, something. But I've got 6 of them. I kept one of this exact size separate, so we can, look at these as well. I just don't want to completely cover them yet because you can't see through this. What's it called? Solution. Oh, there it is. See, look, you wouldn't be able to see that. It is starting to bubble, it appears. Cool. So I have to go teach. Actually, I have to prepare to go teach and then go teach. Oh, you can see it actually is bubbling. It is going. I was thinking it was going to be kind of boring and that it's not actually doing a lot of gas stuff, but it is doing gas stuff. And one can assume that that would be hydrogen, right? I don't know. I'm not a scientist. So that's going to go. Those are oxidizing. That's lots of gas and bubbly stuff going on there. Then there's currently nothing in here except for whatever that oil slick looking business is. I mean, it looks like bits of metal. Is there something in there? Did I put a coin in the bottom of that? I'm almost certain I did not. It's pretty though, huh? It's only been another minute or so, but already bubbles. That's cool, huh? Okay, that's still going. Really do have to go teach. More of this blue cotton cloth. Figure see how it oxidizes as well, because I'm just gotta be waiting to get all the rest of that done. So of course some of it's wicking up into there, but sulfuric acid, of course, much more concentrated than this. Did a real number on cotton. And then this has the permanganate in it. So we'll leave that also for another hour and a half or so and see what happens with that. Quick update before I go teach. I mean, same, I think that's probably done. Stinky, cool, metallic, Terminator looking layer on that. Yeah, still sort of bubbling. And then this has got kind of a cool forest sunset doomsday looking thing on it that is pretty neat. And we'll see what that looks like once it all gets washed off and whatever. All right, so it's been, what is this coming up on, 5 hours or so since this. This is interesting. That's kind of cool, isn't it? How created a barrier around there, or yeah. But that one screw head right there is still going, and really none of the rest of it is bubbling a whole lot. Certainly not that vigorously. So I wonder what's going on with that one spot. And this little guy, again, there's some kind of sludge. I don't know if that's left over from some residue. Anybody have any idea what that might be? And this really cool sunset southwest kind of looking thing that I'm going to be curious what that's like when it's all rinsed out and neutralized and stuff. But this is what interests me the most so far. And can we just ruin it a little bit? Oh, look. Did that all just go away? That was kind of cool. Or will it fall out of solution again? I guess we will find out in 105 minutes or so. Let's put it in here just to keep everything separated. That's a pretty color, isn't it? Oh, okay. Hey kids, that's why you wear goggles. That splattered all the way over into the next thing. Of course I added it really quickly. I was thinking it was going to be less reactive than that. Alright, so I guess now that's pretty much done. Alright, so it's been just over an hour and a half. I just didn't do anything with this. I just moved this back from here because I'm going to chuck all of this into there and let it neutralize. This has gone from that really cool sunsetty yellowed kind of thing to, I mean, completely screaming white, like actually kind of a beautiful white. It was a blue shirt, and it had that kind of bronzy, rusty, yellowy brown, I'm colorblind, to it earlier, and I don't know what happens to make that. I mean, it's been completely bleached, completely. The dyes have been broken down, I'm sure in part by the sulfuric acid, and then oxidized by the permanganate or whatever. But now it's just a cool, that really dark at the bottom, and then white, and then the untouched kind of blue. You can see just at the top, there's a little bit of leaching up to the edge of the beaker. Remember I sort of agitated that this beaker that had the sort of some of that like residue or whatever in it, and then as soon as I shook it, it disappeared, and I thought maybe it would like fall out of solution again, but it hasn't. But what we don't have is anything like the colored, that really dark green or whatever result from when we did like the stainless steel in the razor blade in either of the acids. Now granted, this is not nearly as strong an acid, it's a much stronger oxidizer, but that leads me then to believe that that green in the acid from the razor blade was indeed some kind of chromium sulfate or chromium, some kind of oxide something, because these just plain old screws would certainly not have chromium in them. So I'm finished with this. Let's go ahead and pour this into, this has a lot of baking soda in it already. Okay, so we're left with these, and I'll wash these out, and we'll look at those a little bit later, but boy, they dark. All right, what else? Scary Coca-Cola. Is that some kind of precipitate? I guess there's just some, gosh, it does look like a soda. It looks like a quickly poured soda. That's scary, isn't it? Whew. Ooh, did it? Oh no, I thought it had dissolved. But it might have gotten soft or something. I can't pull it apart with two hands, but can we, no, I'm getting the white part all messed up. Oh, yeah, look. It comes right off. Oh, I soured that beautiful white. All right, so actually, I want to put that in some clean baking soda I'm gonna try to clean that out because that white is like screaming shockingly white. And then we have this horrible sludge. Toxic Kool-Aid. Alright, so that's all done. I'm going to finish washing all of this out, and then we'll come back and take a look at the results. So, what we have left, I mean, it's very, very easily tearing. This is part of the, it's, I don't know, it's difficult to see on these with black gloves, but it has the consistency of paper, wet paper. It's just nothing. This, which I do want to try to keep as clean as possible because I think that white is surprising because it appears, and I will follow up, it appears that the integrity of the shirt has perhaps been maintained. Obviously this blue, I don't want to drop it back in there. This blue part at the top is more or less unharmed. The stuff that was really in the solution here at the bottom, that fell off like it was perforated. I wonder if the white stuff, the white part, you can see it's clearer, sort of, or thinner at least. I wonder if structurally this is weaker, if it has, if it has somewhat been dissolved, or if it's just a bleached white shirt. The one thing that I did think was interesting, and it's interesting but disappointing, took this out, and I thought we would wash it off to have like black aluminum foil. But I started washing it off on the other side, and very clearly what we have is just a whiter, silvery looking aluminum foil. What that means is all of this black is actually just, yeah, look, is just a layer of the oxide. It feels gritty. It feels like ash or sand or something. I mean, not that extreme. But look, it's all just dripping. This is just an oxide layer that formed on the aluminum foil. So it's thick, like it's noticeable, it feels different, but it's just washing completely off. And what that says to me, despite this still being here, and maybe I should try to wipe that off, and maybe that will wipe off as well. But I was surprised at this. I thought this was actually, I thought we had something. It's just foil. That oxide layer formed, and then, you know, there's no chloride ions or anything in here, so it apparently wasn't able to penetrate that oxide layer. This was again 0.1 mole of potassium permanganate and 2 mole sulfuric acid. And again, remember when I mixed them, they didn't react at all. So maybe that means we need, 5 molar sulfuric acid and, 0.5 of permanganate or something. But we will slowly escalate that, see if we can do something different. But I think that's everything. Just as a follow-up, I said that oxide layer or whatever from on the aluminum foil felt kind of like ash, and when I stretch or sort of flattened out the aluminum foil, it also looks like ash. It looks like burnt paper. It's just peeling off.